Hello. So in this video, we'll be looking at the first chapter, algebraic expressions, following on from the Edexcel textbook, and we're going to look at the second section. So 1.2, expanding brackets, we're going to look at expanding expressions with brackets in, right? So we're going to look how to multiply different algebraic terms together. Now, this probably might seem like a pretty simple concept from GCSE, and you should be able to know how to do it. But it is a crucial algebraic a skill you need to learn. And so at the A level, you will be expanding various different brackets, and you need to be quite sharp with it. So it's just a good idea to just go through this section, just have a look at the examples. So you're very, very confident you can do it fairly efficiently. And if you are using the FOIL method um, from GCSE, I would start to try and be able to expand things quicker without using the method, and hopefully going over this will make sense. So let's just start then. So firstly, we need to expand these expressions. So firstly, x plus 5, x plus 2. It's a fairly standard sort of approach. And basically, I guess the way to approach this, as you probably should be able to tackle already, but just consider it term by term, right? So for example, the first term in the bracket, x, then you multiply it with all the terms in the next bracket, right? So if we do that, that's going to be x times x, which is going to be x squared, right? And then we're going to add, and then x plus 2, x times 2, which would be 2 lots of x. And then we're going to do the same with the second term in the right, and then we're going to do 5 times x, which is 5x, and then 5 times 2, which is 10. And then it says to simplify. We can simplify because we have different x terms, so we can collect them together, add them together. So that's going to be x squared and then 7x add 10. Okay, that should be fairly straightforward. And so let's have a look at part B. Now we've got x minus 2y, x squared add 1. And it will be the exact same approach, but it might be looking a little bit trickier because we've got a y, but it's the same approach, right? So we're going to do the first time the x times by everything in the second bracket here. So we're going to have firstly x times x squared, that'd be x cubed. Then you're going to do x times the 1, which should be just x, right? X times 1 is just x. Then you got this minus 2y. I'm going to do the exact same thing, times it by every term in the other bracket. So minus 2y times x squared. Well, that's just going to be minus 2y x squared, right? Not much we can do there. So there we are. And then we're going to have minus 2y times the 1. That's just going to be minus 2y. And yeah, we can't simplify that anymore because none of these terms are the same, right? We have an x cubed term, an x squared term, an x and a y term. So we can't do anything more with that to simplify. So let's move on to part C. X minus y squared. Now, the key thing to recognize here is when you got a square or anything like this, either a cube or whatever with a bracket, you're just multiplying by itself. So you repeat the same bracket twice, okay? If it was cubed, you times by the same bracket 3 times. But here we got a squared, so you times it by itself twice. And from here on out, it's exact same approach again. So start with the x on the first bracket, and then I'm going to times it by every term in the second. So that's going to be x times x, which is x squared, x times minus y, that'd be minus xy. And then I've got the minus y term in the second. In the second term, so we're going to multiply by the other bracket again. So minus y times x, that'd be minus xy. And then minus y times minus y, that's going to be plus y squared, okay? The minus y, remember, the negatives will cancel each other out. Negative times a negative would be a positive. So then y times y would be y squared, okay? Just make sure you're very clear with that. And we can simplify this because xy, we've got two of the same sort of terms, right? So we've got x squared minus an xy minus another xy would be minus 2xy. And then we have a y squared. Cool. And then part D, okay. We have x plus y, and then 3x minus 2y minus 4. And this is a little bit trickier because it's not two terms. Now it's three terms. The second bracket's extended a little bit. We've got more to consider. But the exact same method, okay? So with the first term in the bracket we times it by all the three terms. The only difference now we've got three terms instead of two, but exact same approach. So firstly, x times 3x is going to be 3x squared. Then you're going to have x times minus 2y. That's going to be minus 2xy. Then you're going to have x times minus 4. That'd be minus 4 lots of x. Okay, cool. And then I'm going to do the exact same with the y. Right, the next term in the bracket, in the first bracket, y, and then we do the same times by every single term in the other bracket. So then I'm going to have y times 3x, which is going to be plus 3xy. Then I'm going to have a y times minus 2y, that's going to be minus 2y squared. And then I'm going to have a y times a minus 4, that's going to be minus 4y. Can we simplify it? Yes, I can. Well, there's only one x squared term, so 3x squared. But I have an xy. We have minus 2xy, and then we have a plus 3xy. I have two lots of xy terms, so we can add them together. So 3 minus 2 would get us just one lots of xy. And then I have a minus 4x. There's no other just x term, so it's just minus 4x. Can't do anything with that. And then we have a y squared term here. So we have minus 2y squared. Again, that's the only y squared term, so we can't do anything more to simplify it. And then a minus 4y term again, the only y term by itself. And there we are. Cool. Okay, let's have a look at this example then. So firstly, we're given x lots of 2x plus 3, x minus 7. Okay, so these sort of questions where you have multiple brackets, because we know how to expand two brackets, double brackets, let's just work with that, right? So let's do two brackets at a time. So let's do the first two. And remember, this is sort of a bracket by as well, because this is this x here. If we just say this, and then you can see clearly we've got a triple bracket. Anyway, so let's build the first part then. So firstly, x lot times 2x plus 3. Well, if we expand that out, firstly, x times 2x is going to be 2x squared. And then x times 3 is just going to be 3x. And then we've got a whole bracket here. And then we're going to times it by the other bracket. And then x minus 7. And then we do this double bracket. And again, let's do the first term, then times it by everything, every term in the second one. So firstly, 2x squared times x is going to be 2x cubed. Then we're going to have 2x squared times minus 7 will be minus 14x squared. And then we're going to have this 3x here. So then 3x times x is plus 3x squared. Then 3x times minus 7. That's going to be minus 21x. Okay, remember because 3 times minus 7 is minus 21. And we can simplify this because, well, we have 2x cubed. There's only one x cubed term, but we have, apologies, we have an x squared term here, minus 14, and then plus 3x squared. So minus 14 plus 3, that's minus 11x squared, and then we have a minus 21x there. Okay, cool. Part B, let's do here. Again, we have x, lots of 5x minus 3y, 2x minus y plus 4. Again, let's still focus on the first two brackets first, the first two products. So this is going to be, firstly, x times every term in the other bracket. So x times 5x is 5x squared. Oh, there we are. And then x times minus 3y is going to be minus 3xy. Uh, there we are. And then we're going to times by the other bracket. So 2x minus y plus 4. And again, it looks like a slightly trickier sort of bracket because we have three terms here. but we do the same sort of process. So firstly, the 5x squared term times by every term in the other bracket. So 5x squared times 2x is 10x squared. Then we're going to have 5x squared times minus y. That's going to be minus 5x squared y. Then we have 5x squared times 4. That's going to be plus 20x squared. Okay, cool. Then I'm going to do the same with the second term. So minus 3xy times by everything else in the second bracket. So minus 3xy times 2x, that's going to be minus 6x squared y. Okay. So realise what we've done here. Minus 3xy times 2x. Again, like we did in the other chapter of indices, we got multiple terms together like this, x, y, and a number. Deal with the number first, the constant. So minus 3 times 2 is minus 6. Then x times x is x squared, and then y is y. Okay, so minus 6x squared y. Then the next term, minus 3xy times minus y, is going to be positive 3xy squared, okay? And minus 3 times a minus, two minuses give a positive. And then lastly, we have minus 3xy times 4. That's going to be minus 12xy. And so we have 6 terms here. So firstly, let's collect the like terms. So firstly, we have an x squared term here. So then 10x squared, and then we have a 20x squared here. That's going to give us 30x squared, right? Then we have an x squared y term here and here. So minus 5x squared y minus 6x squared y is minus 11x squared y. Then we have an xy squared on its here, so plus 3xy squared. Then we have minus 12xy. And there we are. That should be simplified. No. Oh, correction. My apologies. The first bit, 5x squared times 2x is 10x cubed. There we are. Okay. So instead, this will be 10x cubed plus 20x squared. Okay. There we go. Spotted that. Um, so yeah, when you good idea to double check your workings and you expanded it right, especially you've got more complicated expansions. And there we are. And I spotted a little not exam tip, but a little tip there. I spotted some of it was a bit off because I noticed the highest power I should be getting for x is x cubed. Because I have an x squared times the highest power of each bracket, x squared and x, right? That should give me x cubed, but I didn't have an x cubed, so I looked back up my working and indeed I misread something. So there we are. So that should be the full expansion. Um, Fully simplified. We can't do anything more of this. All the terms are different. So there we are. Okay, cool. And then part C, we have x minus 4, x plus 3, x plus 1. Now, this is actually a GCSE question. However, it's good to practice. And so the strategy again, we focus on the two brackets first by the cells. So let's pick the first two. So firstly, x minus 4x plus 3. Well, that's going to be firstly x times x, which would be x squared. Then x times 3 would be 3x. Then minus 4 now, the other term. Minus 4 times x is minus 4x. And then minus 4 times 3 is minus 12. And actually, we can simplify this because we have two x terms, right? 3x minus 4x is minus x. So this is x squared firstly, then you have minus x because we have 3x minus 4x, and then minus 12. So it worked out the first two. So this expansion goes to x squared minus x minus 12, lots of x plus 1. Okay, and then we can do the same sort of strategy, right? So then we have firstly x squared times the x, which would be x cubed. and then x squared times 1 would be x squared, so plus x squared. Then the next part, minus x times x is minus x squared. And then minus x times 1 would be minus x. And then lastly, minus 12 times x is minus 12x. And minus 12 times 1 is minus 12. And we can simplify this. Then this will go to where we have only one x cubed term, so that'll just remain x cubed. But then we have x squared minus x squared, but they cancel actually. So we got no x squared terms because in the end. So then the next part will be minus x, and then we have minus 12x will go to minus 13x, and then we have minus 12. Cool. Okay. So yeah, that's sort of strategy, right? We have multiple brackets. Don't forget it's the same method. You just do it. You just work with the first set of double brackets, right? And then you times that result with the remaining brackets. Okay. So yeah. So let's have a look at the next question. Now we are told to expand these expressions as simply as possible. So we can use index laws here, but we've got indices inside the brackets, right? To help us. So firstly, we have minus 3x times 7x minus 4. Well, actually, again, just times the number outside by all the terms inside the bracket, right? So minus 3x times 7x would be minus 21x squared. Okay, so think about that. Minus 3 versus minus 3x times 7x. You times the numbers together, the physical number, the constant. So minus 3 times 7 is minus 21. Then x times x is x squared. Okay. Then with the other term, the minus 4, minus 3x times minus 4 will be positive 12x. Okay. Then part B, we are given y squared of 3 minus 2y cubed. Well, again, same sort of process, right? We're going to times the number outside, the y squared, by every term inside the bracket. So we're going to have y squared times 3, that'd be 3y squared. And then y squared times minus 2y cubed. So what that's saying is y squared times minus 2y cubed. That's going to be your indices, right? So we're going to have minus 2, right? The number in front. But then y squared times y cubed, you should remember, we did it in the last section, when you times into numbers of the same base, remember the base is y, the number, the big number, right? The main number. The same base, so y, but you times in with different indices, the powers, right? You add them. Okay, so y squared times y cubed is y to add 3. Now that will go to minus 2, y to the 5. Okay, so make sure you're confident on that. Okay, cool. Then part C, if we get rid of this now, part C then is asking for 4x, lots of 3x minus 2x squared, add 5x cubed. And again, even though we've got 3 terms now instead of 2, it's the same process again. So we're going to times the number outside by every term inside the bracket. So we're going to have 4x firstly times 3x. That's be 12x squared. Then we're going to have 4x times minus 2x squared. That's going to be minus 8x cubed. Remember, 4 times minus 2 is minus 8. And then x times x squared is x cubed if you add them. Bear in mind that there's a hidden index, a power of 1. So 1 plus 2 will give us the power of 3. And then lastly, 4x times 5x cubed will be 20. X to the 4. Okay, 3 add 1. X times x cubed is x to the 4. Okay, and we cannot simplify anything so far because they're all different terms. Okay, part A we have x squared and x, they're different. We have y squared and y to the 5 for B, part B, so we've got to simplify it. Here we have x squared, x cubed, and x to the 4. They're all different, right? If they're not the same, exact same power, the exact same terms, they're all different. Okay, so we can't do a bit more of that. So let's have a look at part D. We have 2x lots of 5x plus 3. Uh, minus 5 lots of 2x plus 3. And so we've got two different brackets going on here. But that's fine. We can just expand them each of them separately, right? And then we can see what we can do with it. So firstly, the first set of brackets. So 2x times 5x firstly is going to be 10x squared. Then 2x times 3 will be plus 6x. And then for the second set of brackets, minus 5 times 2x is going to be minus 10x. And then minus 5 times 3 is minus 15. And we can simplify this as we have 2x terms, so we can collect like terms, if you will. So firstly, the 10x squared is just as it is because there's only one x squared term. Then for x's, we have 6x minus 10x minus 4x. And then we have a minus 15, a number on the end. Okay, cool. Okay, so the exercise then for this in the textbook, some more practice questions. I guess more slightly harder questions, questions you may see in exam. Okay, but we're given this. So we are told that these three brackets here, they give us this expression. Okay. Don't worry about the algebra, the A, B, C, D. They're just numbers, right? Um, okay, but so it might be how do we get to this? Well, let's start with what we know. What can we do? What can we do to this? We can expand it, right? And most of the time, a good strategy, you see brackets, is to just expand them, see what you can do from there. Okay, so that's what we're going to do. So 2x plus 5y, 3x minus y, 2x plus y. Okay, well, exactly what we've just been doing. Firstly, we expand the first two sets of brackets. So that's going to be 2x add 5y, 3x minus y. Well, that's going to go to, again, I'm going to do the first term, 2x by all the terms here. So 2x times 3x is going to be 6x squared. And then 2x times minus y is going to be minus 2xy. Then I'm going to have a 5y times the everything. So 5y times 3x is plus 15xy. 5 times 3 is 15, xy is xy. And then 5y times minus y is minus 5y squared. Okay, and we can simplify this actually because we have two different xy terms. So we have a 6x squared, then we have minus 2xy and 15xy plus 13xy minus 5y squared. Cool. So now we worked out the first set of brackets. So this will go to 6x squared plus 13xy minus 5y squared times by 2x plus y. Uh, Quite a gnarly bracket, lots of expansions, but we can expand this as well using the same method. Okay, well, firstly the 6x squared term times by everything in the other bracket. So 6x squared times 2x is going to be 12x cubed. Then we're going to have 6x squared times y, that's going to be plus 6x squared y. And then with the other term then, so 13xy times 2xy, well, that's going to be 26. Remember, 30 times 2 is 26. X squared y, okay, because then x times x is x squared, and then we have a y on the end. Okay, then we're going to times 13xy by y, that's going to be plus 13xy squared. Remember, we times y by y. And then lastly, the last term, we have minus 5y squared times by 2x. So that's going to be minus 10xy squared. Then we're going to have minus 5y squared times y. That's going to be minus uh, 5y cubed. Okay. And then can we do any simplification to make it look like this? Okay, well, we have 1x cubed term, so that's just 12x cubed. Do we have, and then what about the x squared y terms? Well, we do. We have one here and one here. That's it. So then we can simplify it to add them together, collect like terms. So 6x squared y and another 26x squared y. 6 and 26 is 32x squared y. Okay, cool. And then what about the next term? We have xy squared, and then we have another xy squared term. So 13 minus 10 would be plus 3xy squared. And then we have the final term we haven't dealt with yet, minus 5y cubed. We can't do anything more with that. There's only one y cubed term. And now it's in this form, right? In the question, it's in this form here. Ax cubed, we have an x cubed term, we have an x squared y term, we have a xy squared term and a y cubed term, exactly in the form. So if you just read off, we can tell that the coefficients, so A would be 12 here, B would be 32, C would be 3, and D would be minus 5. Cool. Okay. Uh, cool. Again, it's important to be able to do that, but there we are. Okay. Last sort of question then. Diagram. We're given a sort of more of a practical question now. The diagram shows a rectangle with a square cut out. The rectangle has a length of 3x minus y plus 4 and width x plus 7. The square has a length of x minus 2. Find an expanded and simplified expression for the shaded area. So it wants us to find an expression for the shaded area, which is going to be this bit here, right, in sort of greenish colour. Okay, so how are we going to do that? Well, we're given information about the rectangle as a whole here, poorly drawn rectangle. And we're given information about the square. Well, I think if we find the area of the rectangle and take away the area of the square here, we're left with the shaded area. Okay. So therefore, the shaded area is going to be area of the rectangle, right? The big rectangle minus area of the square. So then all that's left is to work out what these areas are. Well, the rectangle is obviously base, length times width. So that's x plus 7 times by 3x minus y plus 4, so the two sides. Again, it's algebra, that's completely fine now. But we can expand and simplify, okay? So that's the area of the rectangle, and then the area of the square is here. So it's going to be x minus 2, right? And it's going to be squared, isn't it? So we're going to times by another x minus 2, because obviously squares have the same length, so it just times the length by itself to get the area. Cool. Okay, so then all that's left to do is expand this whole thing out. So firstly, let's deal with the first set of brackets for the rectangle. So firstly, the x, then I'm going to times by f in the other bracket. So x times 3x is going to be 3x squared. Then x times minus y is minus xy. And then x times 4 is plus 4x. Then we're going to have to deal with the next part, 7. So 7 times 3x is 21x. 7 times minus y is minus 7y. And 7 times 4 is plus 28. Okay, cool. And then I'm going to do a minus. And I'm going to put a big bracket. Because then I'm going to do, and then I'm going to put inside it this expansion, right? And then, because then I'm factoring out a negative, right? Because I have a negative here. Okay, so let's do the expansion here, a more simple one. But again, x firstly, so x times x is x squared. X times minus 2 is going to be minus 2x. And then minus 2 times x is going to be minus another minus 2x. And then minus 2 times minus 2 is plus 4. Okay, and then let's see what we can simplify then. So we have an x squared term here. Okay, but there's no x squared term in. I'm gonna ignore this bracket at the moment. Let's just simplify everything in this first part, right? To make it easier for us. Well, in the first part, there's only a 3x squared. Then I have a xy term. There's no other xy term, so it's just minus xy. Then I have an x term, 4x, and then I have another x, 21x, so that'll go to 25x. Then I have a minus 7y, well, there's only one y term by itself, so minus 7y, then I add 28. Okay, then I'm going to deal with this bit, so I'm going to get rid of the bracket, so I'm going to times by negative everything. So essentially the signs change, right, if I times by minus 1. So this will go to minus x squared. and then minus 2x will be plus 2x. And then it will be a plus 2x again. Now, actually, we can simplify this, can't we? Because that will go to 4x, right? 2x with 2x is 4x. And then we have a minus 4. And now we can simplify everything here together to get one final expression. Again, so what about the x squared term first? See where we have another x squared term over here. So that will go to 3x squared minus x squared would be 2x squared. Okay, then I have an xy, so minus xy. That's the only xy term, so that'll just be minus xy. Then I have an x term by itself, so I have 25x. And then I have another x plus 4x, that'd be 29x. And then I have a y term, a minus 7y. But that's the only y term, so that's minus 7y. And then the last bit is these numbers at the end, right? These constants, right? So I have a 28 minus 4, that will be plus 24. Okay, and there's nothing more we can simplify. All these terms are different to each other. So that's simplified, and that is your fully simplified expression for the area. So that's a sort of like a more of an application question of where we can use expanded brackets, right, to solve something. Now, obviously, you won't really be asked, obviously, in exams to expand something by itself. It's a skill that you'll need to consistently use and put into practice throughout the course. Um, and particularly when you move on to circles in AS, there's a lot of hefty expansions you'll need to do for the questions. So it's very good that you get the practice in right now, even though you've done it at GCSE. But it's a good idea that you understand these questions. And as a final remark, when you got simple brackets like this, say for example, like we just had up here, so x minus 2, x minus 2. Let's say x minus 2, x plus 3. Okay. To very quickly expand it, if you haven't already, well, x is x squared, but then instead of manually expanding the x term, so minus 2 times x, and then x times 3, what you can simply do is just add the numbers together. So 3x, a 3 here will be 3x, and then minus 2 will be minus 2x. Simply 3 minus 2 will be plus x, okay? So I'll do that straight away if I have to simplify afterwards, okay? And then obviously minus 2 times 3 will be minus 6. So it's a very quick way with these sort of simple brackets without having to faff about with expanding and simplifying. You can cut right to the chase. It's a little shortcut to recognise if I just add the numbers together. Then I very quickly get my answer without having to do plus 3x minus 2x by itself and then add it together. Um, and yeah, and also perhaps more complicated brackets as well. So minus 2x minus 5, and then x plus 6. Again, it's a bit tricky now because I have a 2x, but it's the same sort of thing. Firstly, 2x times x is simply 2x squared. But then instead of doing 6 minus 5, we're actually doing 2x times 6, which should be 12x minus 5x. Very quickly, 12x minus 5x would be 7x. And then minus 5 times 6 is very quickly minus 30. So you have to be quite quick, right, with expanding brackets of this sort of nature. Um, okay. One final question I wanted to go over, an exam question relating. Well, not related, but it uses essentially the skills of expanding. Okay, that we just looked at. So I think this is a really good level question to test your expanding brackets knowledge and how you'd apply an exam and what's expected for you. So it might be a bit complicated when we go over it. As you get used to the level algebra in the course, but I want to work at the moment if you're starting the course. However, it'll make more sense as you go on. But let's have a look at it. So you're given x is t squared of 5 over t squared of 1, y is 4t over t squared of 1. We need to show this result that x minus 3 squared of y squared is 4. So the way we're going to do it is basically just plug it in because we've got x and y. So we can just simply go from there. So x minus 3, that's going to be plugging x in, that's going to be t squared of 5 over t squared of 1 minus 3 squared. And y squared should be 4t over t squared and 1 squared. Okay, we're not going to equal 4. Why? Because we want to show that it does equal 4. Okay, so when we do this simplification of what we've got here, which looks like a mess at the moment, but eventually it will cancel out to just 4. Okay, and this is where expanded brackets. Hopefully, you can see we're going to be expanding some hefty stuff here. But to start off with, as well, it's just algebraic fractions, right, from GCSE. So if we're subtracting like this, again, we need a common denominator. So if we deal with the part in the x bracket, so the t squared of 5. Well, if I subtract 3, I want to get the denominator of t squared of 1. So I'm going to times minus 3 by minus 3 of t squared of 1 times by the denominator, which allows me to put everything out of t squared of 1. And there we are, that'll be all squared. So now we've got one single fraction, so I can simplify, I can work with it. Add 4t over t squared of 1. Well, at 4t, so 4t over t squared of 1, well, that's simply 4t over t squared of 1 times by itself, okay? So another 4t of t squared of 1, okay? And then if we continue this on, we can expand the bracket now. This 3 minus 3 of t squared of 1, so we'll be left with t squared of 5 minus 3t squared minus 3, okay? Over t squared of 1, all squared. Plus, and now because this is basically times in, because there's a hidden multiplication here between these two brackets. We put brackets together, we mean with times in them, okay? So that be again, and then when you times the two fractions, you times the numerator and the denominator separately. So times the top, so 4t times 4t. Well, that's just simply going to be 4t all squared, isn't it? Okay. And then t squared of 1, that's going to be t squared of 1 all squared as well. Okay. And now I can simplify this bracket again. So then t squared minus 3t squared, that's going to be minus 2t squared. And then we have 5 minus 3, that would be plus 2. And that'd be all out of t squared out of 1 all squared. And then I can expand this. Now, think to GCSE. Usually, when you deal with fractions, you want to leave the denominator, because what we're going to do here is the denominator here. If you see we're squaring, this fraction here is also going to end up t squared of 1 squared. So it doesn't really make sense at the moment when we already have another t squared and 1 squared to kind of expand it and do more work than necessary. Because the idea is, then we can add them together still, the fractions. But like think back to GCSE, you're probably going to want to factorize, right, or whatever, to cancel the fraction. If we expand it, it might be unnecessary work, but we'll roll with it for now. Let's just deal with the numerator. So we're going to add 4t all squared. That's going to be 16. Remember, that's 4t of 40. So 4 times 4 is 16. And t times t is t squared. And I'm going to leave it as t squared of 1 all squared. Maybe we might expand it, but at the moment, let's leave the denominator where it is. Well, then, I'll kind of explain what we're going to do here. Because it's squared again, that's a plus 2. We're going to again square the bottom and the top and the bottom, independent by itself. So minus 2t squared plus 2 is going to be all squared, and then bad line, t squared and 1 all squared. And then I can work with this, and that's still going to be added with 16t squared over t squared of 1. Notice again why I didn't expand it, because I'll still get the same denominator, so I don't need to work or do anything with that at the moment. Okay, well, if I expand it then, so minus 2t squared of 2, minus 2t squared of 2, again, that's just what we did throughout this little video. Well, again, work with the first term, and I'm going to expand times it by everything in the other bracket. So that's going to be minus 2t squared times minus 2t squared. Minus 2 times minus 2 is plus 4. t squared times t squared is t to the 4, okay? Because remember, t squared times t squared, what that's saying is we add the powers, right? Because we've got the same base, remember the t, and we different, well, it's the same power, but we can add the powers together. So t2 add 2 gives us t to the 4. That's where that comes from, okay? Then we have minus 2t squared times 2. Well, that's going to be minus 4, isn't it? T squared. And then again, I can do the same with this next one, this 2, the next part. Again, times by everything in the other bracket. So 2 times minus 2t squared is another minus 4t squared. Then 2 times 2 is plus 4. And I can simplify this because I have 4t to the 4. There's only one power 4, so we leave it there. But I have t squares. I have minus 4t squared and another minus 4t squared. So that goes to minus 8t squared plus 4. And now I can just bring that in. So I've done that's the expansion. So that'd be 4t to the 4 minus 8t squared add 4. And remember, I'm adding two fractions and they're the same denominator. So I can simply just bring them together and add 16t squared. And that would be all over t squared add 1 all squared. Well, then that goes to if I work down here again, I can bring like terms. I have 4t to the 4, so again, only one power 4, but I have a minus 8t squared here and a 16t squared. Well, and minus 8 plus 16, well, that's just plus 8t squared. And then I have a plus 4. That'll be all over t squared add 1. Okay. All squared. Okay, well, let's bear in mind, the answer needs to be equal to 4. Um, what that essentially means is, well, really, whatever this is on the bottom, it kind of just has to resemble this bit on the top. And actually, we can be a bit crafty and notice on the top, we can already factor a 4 out. We can simplify it a little bit. If we take 4 out, that would be t to the 4, add 2t squared, add 1. So then over t squared and 1 all squared. Well then, if we already got a 4, that means actually now this top bit, the fraction inside, has to be equal to this fraction here. This bracket here, the t squared and 1 all squared. They both have to equal, so we can cancel them out to just be left with this 4 here. Well, there is you can factorize this potentially, but it might be really hard to see at the moment. So the best way actually is just expand this instead. Right, I could factorize up here, might be a bit hard work, especially at the moment. But we could also just expand this and see, but we should get the same result here. Well, again, if we expand, we can. This is squared, it's just times it by itself. And now we can just expand this bracket as usual. So again, 4 of t to the 4 add 2t squared add 1. Then again, so I'm going to first deal with the t squared, and then that's going to be times by everything in the other bracket. So t squared add t times t squared is t to the 4. Again, remember, t squared times t squared is t to the 4 because you add them, the powers. T to the 4, and then we have t squared add 1, times 1, that'd be just t squared, right? And then here with the 1, this time. Oh, and then 1 is being times by again everything in the other bracket. So then 1 times t squared is just t squared. And then I have 1 times 1, which is 1. That simplifies to 4 t to the 4, 2t squared of 1. And then that we can collect like we can simplify by collecting like terms. Again, we only have t to the 4, but then we have t squared and another t squared. That's 2t squared. Add 1. Hopefully now you notice the top bit is exactly the same as the bottom, so we can cancel this out. Okay, and therefore we're left with just 4. Okay, because then the other fraction becomes 1. Because both the top and the bottom cancel the factors. And there we are. We just left with 4, and that is exactly what they asked us to show that we get 4 at the end of this. There we are. Nice remark. Wow. I think it's a nice remark anyway. Yeah, so that's I think that's a really, really good final closing question to really test your knowledge of expanding brackets. Um, and show you kind of the level of algebra you might be expected. Again, at first, especially at the start of the course, if you're new as well, this might be a bit of a full-on question, but hopefully you can kind of make sense of it, especially if we've gone over it. And that's the idea. That eventually you get comfortable with the level of algebra as you go through the course, and then you become more comfortable with tackling questions like this. Okay, but I'm going to leave that there then.